functions. Today we're going to be doing polynomial functions and their graphs. So what we're going to be able to do today is identify key features of polynomials based on the equation and based on the graph. So first of all, some vocabulary words to know. Here's an example of a polynomial equation here, and you need to know what each of these things mean. So if I say to you leading term, that would be, does anyone know what a leading term is? What's my leading term? You guys, it's not a trick question. Why is this class so hesitant to be wrong? Yes, it is 3x to the 5th, everyone. What if you would have said 6x to the 4th? It would have been okay. Okay, moving on. So leading term is 3x to the 5th. What do you think the leading coefficient would be then? 3, because coefficients are the number in front of the variable. So I'll skip down to coefficients. So our coefficients would be 3, 6, negative 3, 1, negative 1, and 2. Notice I put the signs with them as well. You guys see? Positives were pluses and minus were negatives. So what degree is this polynomial considered? We see a bunch of different degrees. Which degree? Yep, you got the highest degree. This would be considered a degree 5 polynomial. And our constant term is the term that has no x's with it. So our constant would be plus 2 or just positive 2. Our constant is without a variable. Questions on any of those things? Okay, let's test your abilities then. I'll give you a little quiz. Hey, x minus 2 here. What's my leading coefficient? 1. Oh, see, did he croak dead? No, it was okay that he was wrong. Okay. Coefficients, what are the coefficients of p of x? 1 and negative 2. What's the leading term? X. What's the constant term? Negative 2. And what's the degree? 1. Degree 1. All right, q of x. The leading coefficient is 3. Agreed? The coefficient is just 3. Leading term is 3. Constant term is 3. The degree is 0. If it was 1, right? If it was 1, there'd be an x to the 1. You guys see how this is just 0? Okay, awesome. This one, my leading coefficient is 1. My coefficients are 1, negative 1. Leading term x squared. Constant term, none. Degree 2. Are we good with this stuff? Okay, let's move on. Yes? Yeah, great question. I'm actually really glad you asked. Yes, we need to make sure before we do any of those things to put our polynomial from highest to lowest degree. Great question, in standard form. Okay, so what is considered a, quote, polynomial? So first of all, let's just look at a few things we've seen in the past. Graphs of polynomials of degree 0 or 1 are lines. Right here's a degree 0. It's just a straight line, a constant. And then here's a linear equation, degree 1. Here's a polynomial of degree 2. Either smiley faces or frowny faces. We know quadratics are U shapes. A polynomial of degree 3 looks like this. It's cubic, and then we can keep going on forever. So the higher the degree of the polynomial, the more complicated the graph gets. So here is one thing to note, everybody. To be considered a quote-unquote polynomial, there can be no breaks or gaps. It has to have smooth corners with no sharp corners or points. So right here, this is a piecewise function. Yes, it's a piecewise function, but it is not considered a polynomial because there's a gap. You guys see? Not a polynomial. Is this one a polynomial? No, because there's some sharp edges here. This one would be considered a polynomial because it's all round. This one would be considered a polynomial because it's all round. Do you guys see? Okay, moving on. Now we're going to focus in on just stuff we've already seen, actually. So parent functions are the basic non-shifted functions. So for a line, y equals x. For a quadratic, y equals x squared. Cubic, y equals x cubed, and so on. So we already know how transformations from the parent function work. So if it says to you on your homework today, and it will, graph this as a transformation from the parent function. Your parent function would be x squared. Do you agree for this one? Take off the shift. Then remember we make an xy chart. Plug in some points, negative 2, negative 1, 0, 1, 2. Then that would be 4, 1, 0, 1, 4. And then perform the shift. So inwards we would say this is up 1. A reflection over the x-axis. A reflection over the x-axis affects your y values. So you'll times your y values by negative 1. And then after that one, we add 1. And then we would write down our new xy points and graph them. Can you guys do that without me actually doing any examples? Let's hope so, because we've done that so much. Okay, then just describe the shift. Right 1, up 2. Vertical stretch up, 2. Right 3, down 1. Good, reflection over the x-axis. Vertical stretch of 3, and that's it. So you guys would be good with that. Awesome. Okay, now let's talk about polynomials and behavior, everybody. And behaviors are not what's happening in the middle of the graph, but what's happening on the far left and far right of the graph, at the ends. So I'm looking at the ends here. So right here I have some examples of some different even-degreed polynomials. Even degree. They're all different degrees, but they're all even degrees. Right here I have some examples of some odd degree polynomials here. Now you're looking at the ends, the end behavior, you know the ends. So what do you notice about even degrees versus odd degrees and behavior? Yeah, evens are the same, either up and up or down and down. Does everybody see how the end behavior is always the same? Very good. And odds are always opposite end behavior. That will always happen. That's your first rule. Evens will have up and up or down and down, and odd degrees will have down and up or up and down. Now if you had to guess, possibly, what do you think makes something up and up versus down and down? Just a guess. Positive or negative? Yes. So you're saying, with a quadratic, what flips it to a down and down? A negative. So this will have a positive leading coefficient. This would have a negative leading coefficient. Positive leading coefficient. Negative. Do you guys see? Okay, awesome. So let's look here. What's the difference, do you think, between positive and negatives? Like, which one would make it down and up versus up and down? If you had to guess, it's okay to be wrong. Down and up versus up and down?
Down and up, it's like the amount of bigger, so it's positive.
Yes.
Up and down, it's going up and down.
Yeah, so guys, listen to what she just said. If we're going down and up, aren't we increasing over time? So that would be a positive in front. If we're decreasing over time, that's because we have a negative in front. Does everybody see what I'm saying? Positive in front, because this is increasing over time, negative in front. So that is, right here is a picture of the first, those are the rules we need to know for end behavior. Even degrees will have up and up or down and down. If it's positive leading coefficient, it's up and up. If it's negative leading coefficient, it's down and down. Now I can cover up the middle, we're not talking middle. Does everybody see? And then with odd degrees, it's going to be down and up. We always read it from left to right, so down and up. If it's positive in front, it'll be down and up. Sorry. And then right here, if it's odd degree and it's negative in front, it'll be up and down because it's decreasing over time. Now we also have to be able to state it in calculus notation or formal notation. So that means, what do you see happening? So everybody, this reads, as x goes to positive infinity, it's asking us, where's our y values going? Where's f of x going to? Positive infinity, isn't it, everybody? As x goes this way, isn't y going up forever? Okay, as x goes to negative infinity, where's f of x going? Y values are going to positive infinity. Does everybody see? As x gets smaller and smaller, doesn't y get larger and larger? Yes? So it goes to infinity. Which makes sense. Look, up and up, infinity, infinity, up and up. Do you guys see it? Okay, that'll always happen for up and up. Okay, now down and down. As x goes to infinity, where's f of x going? Negative infinity. And then as x goes to negative infinity, f of x is going to negative infinity again. Okay, let's do this one. As x goes to infinity, if it's down and up, f of x is going to positive infinity. As x goes to negative infinity, f of x is going to negative infinity. Which makes sense. Look, that literally says, well, we go from left to right, so that's down to up. Okay, but if we have a rough picture of the graph, isn't this really easy to do? So that's what we'll have. Okay, as x, with this one with up and down, as x goes to infinity, f of x goes to negative infinity, and as x goes to negative infinity, f of x goes to positive infinity. Any questions on that? You have to be able to write it both ways. Okay, awesome. Let's test our abilities now. This is like how the homework will state it. So it says right here, state the end behavior of the polynomial. So this should be your thought process. The first thing you do is say it's an even degree, correct? So it's either up and up or down and down. It's positive in front, so it must be up and up. Does everybody see how to do that? Now, why did I draw a rough picture? So that when I do formal notation, it's easy. So now it's in words, up and up. So now we'll say as x approaches infinity, f of x is approaching infinity. As x is approaching negative infinity, where's f of x approaching? Positive infinity. So that's why I always draw a rough sketch. Okay, looking at this one, this should be your thought process. It's even, so it's the same end behavior. It's negative, so won't it be down and down? I'm just going to write D and D. Okay. So then as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x is going to negative infinity. Okay, good. I can't fit that. Okay, next one. You'd say it's an odd degree. It's positive. So won't it be, which one? Down and up. Isn't it increasing over time? Does everybody see? So down and up. So then when you do this, as x is approaching infinity, f of x is approaching, look at the rough picture, infinity. As x is approaching negative infinity, f of x is approaching negative infinity. Okay, awesome. And then the last one, odd, opposite, negative, so it's going to be like this over time, decreasing, right? Up and down. And then your as x is going to infinity, f of x is going to negative infinity. And as x goes to negative infinity, f of x is going to positive infinity. Questions on how to do end behavior? Okay, it's pretty straightforward. You just need to know those two things. All right, now let's look at the middle. Oh wait, we're gonna come back to this in just a second. Okay, now we're gonna look at the middle of the graph. Now we don't know how to do end behavior. Let's focus in on the middle. So let's focus in on the idea of zeros of a polynomial. Can anyone tell me what a zero of a polynomial is? Yep, x-intercepts, which are also known as the solutions to a polynomial, right? X-intercepts are solutions. So we can call them zeros, x-intercept, solutions. They all mean the same thing. So right here's an x-intercept, here's a solution. Right here's a zero, it's a solution. Right here's a zero. Do you guys see how those are all x-intercepts? Okay, awesome. Now, can you tell me in the past, if I gave you an equation of a polynomial, how have we found the zeros? Set it equal to 0 and then do what? How did we do that? You're right? Factor it, right? Everybody, if we have something factored, can't we find the zeros? Isn't that the whole point of learning how to factor? So we can then set them equal to 0 and solve. Okay, factoring. That's how we find zeros of a polynomial. So if we were going backwards, isn't it true that x equals negative 3 is a solution here? Yes? X equals 1 is a solution. X equals 6 is a solution of this polynomial. Well, if that's true, if x equals 1 was a 0, what would have been the linear factor that gave us 1 as a solution? X minus 1. Does everybody see how this polynomial, if it has 1 as a solution, will absolutely have x minus 1 as a linear factor? So what else is a linear factor? X minus 6. What else is a linear factor? X plus 3. Any questions on that? So can you go back and forth? Okay. So let's go ahead and practice finding the zeros, and we're going to state their multiplicities. I'll talk about multiplicity in just a second. Okay, notice this is already factored, making finding the zeros very easy. X equals 2 and negative 3. Now they only happen one time, so that's called having a multiplicity of 1. If we have multiplicity of 1, we don't need to write out multiplicity of 1. Okay, let's move on to this one. Now, if we have x minus 1 squared times x plus 3 cubed, I always have people say, should I multiply this out? No, finding zeros, we want it factored, don't we? So we want it as is. Technically, this is this. X minus 1, x minus 1 and x minus 1, because there was 2 of them. We have x plus 3, x plus 3, x plus 3. Does everybody see? So we get 1 as a solution how many times? 2. So we'd say x equals 1 with multiplicity of 2. That means it happens 2 times. Right here we'd say x equals -3 with multiplicity of 3 because it happened 3 times. Which, how many zeros is that? 1, 2, 3, 4, 5. You guys see? Okay, awesome. Now right here, so we'd have to factor this one. We'd pull out an x, then left would be x plus 2. So my zeros are x equals 0 and -2. You don't need to write multiplicity of 1. Okay, looking at this one, x equals 0 with multiplicity of 2. Do you agree? X times x. And then we have x equals 1 and x equals -2 with multiplicity of 4. Okay, good. I think we're getting the picture here. Just a reminder, if we have a quadratic and it's not factored, like this one was, we've got to factor it. Well, multiplies to be -6, adds up to be 1, a times c adds up to be b, right, everyone? So 3 times 2, which one's negative? 2, can I quick factor? Yes. So this quick factors to be x plus 3, x minus 2. So therefore my solutions are -3 and 2. Do you agree? Okay, awesome. I think we're getting the picture here. So x equals 0, x equals 1, x equals -3 with multiplicity of 2. So we just saw how multiplicity is written. Multiplicity of 2, 4, 2, multiplicity of 3, multiplicity of 2. Now let's talk about what's happening when we have multiplicities greater than 1. 1 or greater. So everybody listen. The shape of a graph near the 0 will either cross through or bounce. Do you guys see how this one's bouncing? And this one's crossing through. That will always happen. It'll either cross through the 0 or it's going to touch the 0 and bounce. So let's look at this. X minus 3 squared. Isn't my 0 x equals 3 with multiplicity of 2? And here it is, touching at 2. And it's, touching at 3. It's touching at 3. And what's it doing? Bouncing back up. Okay, interesting. Let's look at this one. We get x equals -4 with multiplicity of 3. So here it is at -4. What's it doing? Crossing through, isn't it? Just crossing through, everybody. You guys see? So what's happening is when we have even multiplicity, not even degree, multiplicity. When we have even multiplicity, it will always bounce at the 0. When we have odd multiplicity, not odd degree, odd multiplicity, it will cross through the 0. That is another rule you need to know, which no one's writing, so I'm confused. So, do you guys all get it? Okay, even multiplicities will bounce, odd multiplicities will cross through. So here's some examples. So if we have x minus 2 squared, x plus 1 cubed, here's the graph. I'm showing you the graph. Here it is, that's the graph. So we would say that, isn't it true that x equals 2 with multiplicity of 2? And x equals -1 with multiplicity of 3. So doesn't this one have even multiplicity? So it should bounce. This one has odd multiplicity, so it'll cross through. Let's look at our graph here. So we should be crossing at 2 and -1. There's -1, there's 2. Now at -1, since it was odd multiplicity, it came up and crossed through. Do you guys see? Then at 2, what happened? It bounced back up. Even multiplicities bounce, odd multiplicities cross through. Okay, let's see, looking at this one. X equals 1, x equals -2 with multiplicity of 4, and x equals 3 with multiplicity of 5. So will this one cross? X equals 1. It'll cross. Multiplicity of 1 is an odd multiplicity. It'll cross through. Look at the graph. Let me scroll up for the people in the back. Look at 1. Is it crossing through at 1? Yes. All right. How about -2? It has multiplicity of 4. What's happening at -2? Bouncing back up. And then at 3, it's a multiplicity of 5. You see how it's just crossing through. Okay, we're going to use the idea of end behavior zeros and bounces to now graph. It's actually really straightforward. So here is the first example. Graph the polynomial. You take these 3 steps. They're actually very easy steps. Graph the zeros. So you have to find the zeros, then graph them. Then you'll draw in the correct end behavior. And then third, draw in bounces or crosses through at the zeros. So with this one, it's not factored, so I'm going to have to factor it to find the zeros. So I pull out an x, So then left would be x squared minus 2x minus 3. Agreed? I got to keep factoring the quadratic. What multiplies to be negative 3 and adds up to be negative 2. 1 times 3, negative 3. Can I quick factor? Yes. So I have an x. I have a x plus 1. And I have an x minus 3. So now the first step is to find the zeros. X equals 0, x equals negative 1, and x equals 3. So we're going to plot those. That's the only place, you guys, if those are the only solutions, those are the only places that can cross the x-axis. So notice I plotted my zeros. Second step is to draw in the correct end behavior. So now we're going to go back and start with end behavior. You look at the leading term. It's odd, so it's opposite. Agreed? It's positive. So what would it be? Down and up. So now what you're going to do is go to the furthest 0 to the left, and it's going down out of that 0. Then go to the furthest 0 to the right, and it must be going up out of that 0, down and up. And now all we have to do is go through and start tracing this graph and putting it together and do bounces or crosses. Now because all these zeros are multiplicity of 1, it will cross through each one. So look, I start here and I start tracing. It's going to cross through, true? Cross through. Now it's got to come back down at some point, doesn't it, to go through the 0? And isn't it going to cross through? Cross through, and then it's going to come back and go up and cross through that 0. Now, we don't have to be, like, obviously this could be clear up here. Do you guys see? We're doing rough sketches. We can't use a calculator, so we can't find max and min, like, without a calculator. So we're doing rough sketches. That's all you have to draw in. Pretty easy. Let's do another one. Okay, so first we got to factor it. So I would pull out probably a negative x squared. So divide by negative x squared, divide by negative x squared, divide by negative x squared. So then left in my parentheses is 2x squared plus x minus 3. Now we have a quadratic, and we're going to have the long factor because our leading coefficient's 2, so it multiplies to be a times c, what multiplies to be negative 6, and adds up to be 1. 3 times 2, negative 2. Long factoring, what are the steps we take? It's been a while. Drop. Good. Drop and break. So drop, drop. So we're dropping down 2x squared. We're dropping down negative 3. And then we're breaking down our middle term as these two factors but with x's. So it doesn't matter order, so I'm going to go with minus 2x first, plus 3x, and then we factor by grouping now, right? So I'm going to group. I'm ignoring this negative x squared for a minute. Pull out a 2x. So then left is x minus 1. Pull out a positive 3. Then left is x minus 1. So now I can factor out x minus 1, can't I? So then it divides out, and left is 2x plus 3. And then we won't forget we originally factored out negative x squared. So our first step is to now find the zeros. What will my 0 be there? X equals 0 with multiplicity of 2, x equals 1, and x equals negative 3/2, and since I have to plot it, I'm going to do it as a decimal, so negative 1.5. Okay, so first step is to draw in your zeros. It crossed at 0, negative 1.5, and it crossed at 1. Now we'll go to our second step, draw in the correct end behavior. So I go back to standard form up here, and I say it's even, so it's the same. End behavior, it's negative, so it's going to be down and down, right? So go to your furthest 0 this way, it's going down out of that. Furthest 0 that way, it's going down out of that. Now, we're going to trace this to fill in the dots, everybody. So looking at this, we're coming up and, should we be crossing through this or bouncing? Negative 1.5 is a cross. It's multiplicity of 1. It's an odd multiplicity. So then are we going to have to come back down? Now at 0, should I be bouncing or crossing through? Bouncing. So now that I've hit 0, I'm making it a round corner. I'm bouncing back up. Don't make it a sharp corner because then it's not a polynomial, right? You see how I just bounced back up? And then it's coming down, and isn't it just crossing through 1? And we've done our rough sketch. You have questions on that? Okay. Let's do we're going to fly like a maniac through these next two, because you have to remember how to factor these ones. How do you factor something that has 4 terms? Factoring by what method? Grouping. You guys are so awesome for remembering. You guys are just so great. Pull out an x squared, then left is x minus 2. Pull out a negative 4, left is x minus 2. So I'd pull out x minus 2. So it divides out. So left is x squared minus 4. Can't that factor more? What would that factor to be? X plus 2, x minus 2. Aren't those two perfect squares? And they have a negative, a minus sign. So they're conjugate pairs, if you can remember. So we have x minus 2, and then we this factor to be x minus 2, x plus 2. So our zeros are x equals 2, multiplicity of 2, and x equals negative 2. So it's crossing at negative 2 and 2 only. Those are the only places it can cross. Now draw in our end behavior. It's odd, opposite, it's positive. So isn't it down and up? So this 0 it's going down out of, this 0 it's going up out of. Now let's go up to negative 2, and should I be crossing through or bouncing down? So I cross through, then I'm going to come back down, and then when I hit this point, should I cross through or bounce? Bounce, so that makes sense because it's going ba-dink and going back up. Pretty easy. What if it's already factored? I want to just talk about it real quick. So if it's already factored for us, our life is very easy. This negative 2 will not affect your zeros. We have a 0 of x equals 1. And x equals negative 2, multiplicity of 2. So we're only crossing at 1 and negative 2. Next thing, the reason we have to be careful is because the negative 2 will affect our end behavior. So isn't it true that for end behavior, all we need is the leading term? So I need to actually not multiply out the whole thing by any means. I need to multiply out the leading term. So what we really have is negative 2, x minus 1, x plus 2, x plus 2. So watch me multiply out the leading term. Negative 2 times x times x times x. That would be negative 2x cubed, right, everybody? So now we know it's odd degree, it's negative, so isn't it up and down? Up and down, decreasing over time. So I'd go up out of this 0, down out of this 0. Now we're coming down at that negative 2. I should bounce, and then I should be crossing through. Okay. Awesome. Okay, this is the last slide of the lesson. So we already know how to do this. So if I said to you, what is the local maximums? What is the local minimums? Just a reminder, we just write them as xy points. Isn't this a max? A local max? So you would say negative 4, 4 is a local max, and 3, 7 is a max. A local min would be 0, 1. What would be my local max here? Negative 4, 2, and my local min would be 1, negative 2. That is the end of the lesson. So, go to the homework you have on your paper and get going on it.